Right now, as you're watching this, there's a star spewing out tons of high-energy ionized particles, as well as deadly radiation. These particles can boil away water, strip atmospheres clean, and can be fatal if absorbed by a human. We don't really think much of the sun other than just a ball of gas that emits heat and light. And sure, with our eyes and our pathetic visible spectrum, it does appear pretty boring. But the sun emits in nearly all wavelengths, and each tell a different story. Today, we will be looking at the more dangerous, high-energy wavelengths, such as those in the UV spectrum. Thankfully, most of this stuff is blocked by our atmosphere, but that also means that we need a satellite in space that can detect UV light and map it into our visible spectrum to see it for ourselves. Doing so will allow us to see the sun for the true beast that it is. A churning surface of superheated gas and these massive loops of particles reaching into space and flashing in UV light. As well as this, the sun is emitting a constant stream of high-energy particles, but let's take a look at what causes all of this. There's the sun's magnetic field, which is the primary source for all of this activity. It's created by something called dynamo theory, which I'm going to leave for its own video, because I think this page turner really needs its own video. But essentially, there are 3 requirements for dynamos to kick in and create a magnetic field: kinetic energy provided in the form of rotation, an electrically conductive fluid medium, and an internal energy source to drive convective motions within the fluid. Or, in English, we need something that spins, is conductible, and has a power source. The sun spins. That's our rotational energy. As for the conductive material, the sun is primarily made up of hydrogen and some helium, which are at room temperature gases, and gases, including these, generally don't conduct electricity. However, under the extreme heat and pressure of a star, the gas's nuclei and electrons separate into a soup of protons, alpha particles, and electrons. This is plasma, the 4th state of matter. That's right, 4th. Your elementary school teacher straight up lied to you. And because of plasma being polar, it is very conductive. So that's where the conductive material comes from. And finally, we need a power source to heat up this plasma. It's a star. I think we're good here. So those 3 elements, using dynamo theory, generate the sun's magnetic field. This powers nearly all solar activity, including the solar wind. Oh right, I should tell you what that is. The solar wind is a constant flow of high-energy ionized plasma. This is significantly less dangerous than the other stuff we'll get to, but it's still very dangerous. How dangerous? The difference between Earth and Mars dangerous. The solar wind can rip apart DNA, boil away atmospheres, leaving water to be evaporated. It originates from an outer region of the sun called the corona, and since this word somehow managed to get into 2 of my videos in a row, and I really don't want to repeat my joke again, we are just going to be professionals about this. The corona is just above the sun's photosphere and can occasionally have these massive dark holes called coronal holes. This happens when the sun's magnetic field does not get looped back into the sun, causing plasma to escape and creating the solar wind, which are guided by the solar magnetic field. Because the sun spins, plasma inside the sun moves, but not at the same rate. Plasma at the equator moves much faster than at the poles. This can result in the sun's internal magnetic fields to get twisted into knots over time. These images from NASA's SDO spacecraft show particles forming massive loops, often several times the size of Earth, as a result of this. These also have tons of stored energy. Sometimes, because of the loop becoming unstable, that energy gets released in a violent and chaotic eruption of plasma. We call this a coronal mass ejection, which are sometimes, but not always, accompanied by a solar flare, which refers to an intense amount of high-energy light released by the sun. Both of these are extremely dangerous. But I have been saying that for a lot of things in this video, and it raises an important question. If all of this solar activity is so dangerous and occurs on the nearby sun, then why isn't the Earth just some desolate wasteland? And the answer to that is yet again dynamo theory. The same magnetic lines that propel plasma towards us can also hypothetically deflect it, and that's exactly what happens. Turns out, the Earth also uses dynamo theory to generate its own magnetic field using its rotation as kinetic energy, its molten iron core as a conductive fluid, and its hot inner core as a power source to form convective loops. Because of the way that the solar wind interacts with the Earth's magnetic field, the day side gets compressed and squashed, while the night side gets stretched out into space. And that's pretty much all a normal amount of solar wind does to us, because most of the solar wind is deflected, leaving only a negligible amount to be absorbed by our atmosphere. However, CMEs are a lot more interesting because they have their own magnetic field, which, if lined up correctly and has just the right polarity, can merge with and peel back the Earth's field, causing a buildup in pressure as well as energy. And if the CME is big enough, it can cause that energy to be released, sending electrons and charged particles at the Earth's poles. These particles can then interact with the Earth's polar atmosphere, causing it to glow, and creating what we call the auroras. The negative impacts of CMEs on humanity depends on the CME size. A smaller one, just strong enough to trigger the northern lights, may temporarily disrupt satellites, and that once-in-a-lifetime superflare CME duo could expose high-flying planes to radiation, fry satellites, and cut power and communication on the ground, especially near the poles. But hey, at least you will be able to see those massive auroras even near the equator. Thanks for watching, everyone. I hope you learned something. Remember to like, sub, and leave a comment for any questions or critiques, or even a video idea. See ya!